So I'm Mathieu. I'm data architect at Deezer, and here is Bouabca, who is a data scientist at Deezer. And today we want to talk to you about Deezer Flow, which is one of the main Deezer features, which is based on the recommendation algorithm. I will start with a little bit of context, and then I will present to you the initial system we built 2 years ago. And then Thomas will keep on with our content tagging system and how we used it to build a live adaptive algorithm, and then a conclusion. So, just a few words about Deezer. You may all know that Deezer is a music streaming service. We have about 6 million paying users who can listen to more than 40 millions of tracks. Deezer is available in more than 180 countries. There is a wide range of users' activity on Deezer. Some users may log in to listen just few tracks, but at the opposite, some other user may stay on the service and listen up to 100 or 200 tracks in the same day. Recommendation at Deezer is included in several features. For example, there is personalization in the search engine results. There are also tailor-made playlist suggestions on the home page. And there is lots of personalized radio and Deezer Flow. So, 2 years ago, the product guys come to see us with a new project. Indeed, they state that when they log into the service, users don't really know what they want to listen to right now. Indeed, browsing their library can require lots of clicks and can be tedious. Digging into new album release to discover some new music can be painful too. So we wanted to add a magic play button that will do that for you and select the right music you just want to listen right now. That's not easy. Obviously, the music you want depends on your musical tastes, but there is also lots of contextual parameters. You may want to listen to different music when you are at home or when you are at the office. Maybe at some time you want some calm music, and in a later session you want some more energetic one. You may want different music on the Monday morning and on Saturday night, and so on and so on. An interesting debate we still have is whether we should ask questions to the user or let the user control the recommendation, or if we just have to analyze the behaviors and let data science do the magic. So, this is a huge problem. We decided to start step by step. And what we already had at this time was user likes. I mean, user can add albums and playlists or likes artists on the application. We also have user streams logs, and we can know if a user have listened a track, if he have listened it entirely, or just skip at the half. And we already developed an album recommendation algorithm based on a classical collaborative filtering approach. So our first strategy is to prepare a track list offline every day for every user and deliver it to the user when he comes to the video. To prepare this track list, we just mix tracks from the user library according to his listening habits, and we add some new tracks coming from recommended albums. Okay, that works if we have data about users, but for a new user coming into Deezer, we don't have any data. So we have to do something different. When new users are creating an account on Deezer, they fall into an onboarding process where they ask to select some musical genres and some artists. So basically, we just build a track list online this time using the artists they like and similar artists. If the user do not give any information, we can do better than fall back to top tracks in the country. And what we expect is that within a couple of days, we will have enough usage data to come back in our first case. So this was the initial release of Deezer Flow 2 years ago. We have a track list that fits user tastes, but obviously it doesn't fit at all user mood. It do not adapt to contextual information. To improve on this, we think we need to immediately take into account users' interaction. If a user like a track, listen it entirely, or skip it, we have to take it into account and refresh the track list as soon as we can to propose a better track list. And indeed, to select the right music the user wants, we think we have we need more insights into the content of the track to know what the user wants to listen again and what he do not want to listen again. So we decided to go to a more content-based approach, and that's what Thomas will talk about.
Thank you. So yeah, the more content-based approach. So first of all, we need to characterize our content. We need to characterize our tracks, our albums, our playlists, and we need to gather data to characterize those items. When I mean characterize, I mean, for instance, the genre, but for also the decade, the country where the tracks or the artists come from. Also, the mood of the tracks, if this track is energetic or it's calm, chill out, etc. So we need to gather some data to characterize all those items. So we have different kind of sources. First of all, we take the metadata from the music providers. We can also have metadata from some partnerships. We also have the expertise of our Deezer curators. Some people in Deezer, they are experts in music, and so they can analyze the content, they can give some advice, and which is also important, they can correct when the whole system has some mistakes, and they can alert and they can detect some obvious mistake. One other source is to analyze the playlist of our users. For instance, if many users put the same track in a playlist and they call this playlist the same rock playlist, for instance, so we can consider that this track is a rock track. Another source is to call open sources on the web. And finally, we have a research and development team that can help to analyze the signal of the content. And so we could extract some feature. For instance, we can use some deep learning, and so we could characterize some tracks, for instance, to consider if there's a male singer or a female singer. And so, with all those kind of sources, we have to gather them. And so it's a huge challenge because all those sources are different. And every day, we have millions of tracks, millions of artists, millions of playlists to characterize with hundreds, thousands of different possible tags. So we are really accurate. We need to have great quality because 140 characterization and the user has some bad content, so that's really not what should happen. So that's why we monitor every sources. We also have some offline benchmarking, and of course, that's a work in progress. We also studying lots of metrics to improve our systems. So, when we have this database of tagged items, we can now produce a new architecture to our live algorithm. So we still continue to compute offline some data. Every night we compute the user data. We also compute the characterization of the items, and then we put the user data in an SQL database, and we put the characterization of our content in an Elasticsearch index. So when someone comes and wants a track list from Flow, we gather its data from the SQL, but we also gather some recent action from a memcache. So if you have listened some tracks 1 hour ago, if you have done some action like a track or skip a track, we take that action in consideration, and then we request Elasticsearch. So the whole algorithm is in this black box, and so that's what we are going to see now. We're going to open this black box, and I will show you how this live algorithm works. So as I said, we gather lots of information, computing offline and recent actions, and then we produce a tag profile for each user. For this user has listened a lot of electro music. He had some artists that were indie, electro, etc., etc. So with all this information, we create this tag profile, and we use it to request Elasticsearch. So now we have track lists that fit with this profile. That was the first approach of the live algorithm, but there are some limitations. The main limitation is that this tag profile is flat. That means that we mix every tag. If a user like jazz, and if a user also like electro, in this profile, the tag jazz and electro are mixed, and so we could serve him jazz electro, but he just wants to listen only electro or only jazz. So we move to another step for our live algorithm, and we decided to clusterize every user profile. That means that now we do not have a flat profile, but several different sub-profiles for each user. So here, for the same user, you could have this small cluster with electro indie, another one with funk afrobeat, another one with folk, and then we do not do only one request, but 3 different requests. We have then 3 different track lists, and then we mix it and we throw it into the flow. As you can see, the proportions are different. That means that this user, we really love electro, and he likes funk, and he also likes more folk. So for the first step, we will serve him a lot of electro, and few funk, and a bit more folk. So that's the initial step. But let's say that this user is not now in the mood to listen electro. We don't know, maybe it's Sunday morning or whatever. So we could analyze its feedback. So all the electro tracks we will provide, it will skip it, but it will love the funk track we provide. So we analyze all this feedback online, and then when we request other tracks, we will provide him more funk track and less electro. That was an example for the genre, but with our tag characterization, we could also consider if he likes electro, but chill out electro and not energetic electro, we could then adapt to what he wants to listen to the moment. That's why we can say that the flow is an adaptive algorithm. So we presented lots of algorithm, lots of improvement, and that's the end of our journey. And the question is, how we improve our algorithm? That's a fair question, and that's everybody asks, and that's what we are also wondering. So that's why we do A/B testing. That's something I will not go further on that. You will know how to do that. So that's a main way of analyzing if our algorithm works, and then we have proved that our algorithm now are better than previously. Just to conclude, so now, as I said, we could fit to user mood. We also have increased performance on first day because we don't need more data than in the first version of the flow with everything was computed offline. So that was really an improvement. And what's next in the future of the flow? I can announce you that there will be another algorithm coming soon that will mix the content-based approach and the collaborative filtering approach to take the best of both approaches. And we also will have more improvement to adapt more to the context. Finally, because we have a lot of work to do and we have wonderful features to develop, so we're hiring and we need some people for data scientists, data architect, search scientists also for search motor engine. So visit the website, join us, talk to us after that. So thank you very much for your attention. If you have some questions.